Our next presenter is Dr. Elizabeth Johnson, Assistant Professor of Education in the School of Education. Dr. Johnson earned a Master of Arts in Teaching Mathematics, a Master of Science in Statistics, and a PhD in Educational Research from the University of South Carolina. Dr. Johnson has served as a full-time instructor in the Statistics Department at the University of South Carolina and has spent 2 years as a visiting assistant professor at the College of New Jersey. Her research interests include statistics education, focusing on teacher training, the use of technology in the classroom, and psychometrics. The title of Dr. Johnson's presentation this afternoon is The Role of Statistics in Educational Research. Please welcome Dr. Elizabeth Johnson.
Thank you. As my colleagues have said, I'm very honored to be here representing the College of Education. Very pleased to talk about what the wonderful work we're doing in the College of Education as far as research, and to talk about some of my recent projects. When I was asked to do the talk, I was looking through all of my projects, trying to decide which one of these I wanted to talk about. And as I was talking to some of my students in ed research, one of them noticed I used the word we a lot. You know, we did this, we did that. And it dawned on me that any of the research that we do is not singular. It all takes a group of people working together. So I'm going to go through some of the projects that I've been involved with, just to show you how you're able to work with so many different wonderful colleagues when you do research, and how that can be used in the classroom to show what how teamwork can be built. So a few projects that I'll talk about. One is the use of rubric development for high-stake testing. Another is investigating math anxiety among pre-service teachers, not adults, pre-service teachers. And some other projects that I've been involved with. My first research project, well, not first, but one of the most recent ones, one of the ones I've enjoyed the most, is started with these words, what if? And we all use them a lot. But these two words came up in 2003. As a high school teacher, I was invited to be part of the AP Statistics reading for the first time. And if you've been a high school teacher, that's like being a rock star. They fly you out to places, they put you up, they pay you to do this, you do it for free. Because it's so much fun to be able to have that whole week of working with colleagues in your field. It's a great professional development experience. But the first day you arrive, people are training you to how to grade papers. Well, as a teacher, this is the first time I was ever faced with someone telling me how to grade papers. I knew how to grade papers. I don't know what they were meant to tell me what to do. So they sat down and said, no, this is how it's done. And they had developed rubrics for grading these free response questions. And as you're sitting there, we are all going, what if? What if I had written this rubric? How would it have been different? So this what if led to several years of going back and getting more comfortable with this process of rubric development and scoring. And some of the what if questions that kept on occurring to me is little things, but some of the questions didn't allow for partial credit, right or wrong. So then you go, well, what if I had put partial credit in there? How would that have affected the score? What if we have to combine subpart scores to a whole score? Well, what if you combine those differently? How would that again affect the total score? And the last one is sometimes we had people who wrote rubrics that were really tough. And this came into play, I think, in the second year of grading. My soon-to-be PhD advisor, I invited him to come. I said, you've got to see this. This is the most amazing experience. So as we were sitting there doing the training, I gave him the question. I said, write your answer. So he was writing his answer. When we scored it with the rubric, out of a score of 0 to 4, he scored a 1 by rubric. I'm pretty sure he knew more statistics than a 1 represented. But because the rubric was written in such a way, it didn't allow for that ability to show. At that point, he goes, okay, you're on to something. So we were able to then proceed. So the way we analyzed this, it took two parts. One was a mock AP exam. We had instituted this at the University of South Carolina around 2002, in which high school students were invited to come to the campus, take a practice AP exam, and 2 weeks before the prior one, so they get experience. So we had this mechanism in place. Since then, we have done this for 7 years at USC. When I moved to the College of New Jersey, we did it there, and last year we offered it here. We had 2 local schools show up. I worked with a friend of mine that teaches at Clemson University, and we were able to do that together, and we hope to do it again this year because it's a great experience to get the high school kids to come onto campus, and it's a good learning environment for teachers. So that was our first method to it. And our second was a simulation study. Because we were like, okay, we can show it in small scale, how these changes would affect, but how would it work on a grand scale? So I guess we're thinking big as opposed to small. I was able to, after years and years of, it seemed like, of trying, College Board released their 2007 operational data to me. At that point, the people at ETS were quite jealous. They go, how did you get College Board to give you data? We can't even get data from them. But I think it was wearing them down. Having this real data allowed me to develop the simulation model. The simulation model allowed us to apply things that we saw in the mock exam to see what they would look like on a larger scale. So we basically had to develop an entire test. We didn't want one that was out there. So basic questions on an AP Stat exam has a basic inference question, so we developed a basic inference question. And with every question we developed 3 different rubrics. So we had our standard rubric, the one that allowed for the partial credit that we were interested in, and then we had the nuclear rubric, the stricter one that no one could pass. You know, we all had those teachers. We then developed an experimental design question. That's another one of the 4 concepts that are part of the AP Stat curriculum. That was from our trip to Peru, so we were able to, that was kind of a collaborative project, but that was fun. So this was a basic experimental design where you're asked to put subjects into treatment groups, explain how you're going to randomly assign them to the treatment groups, what kind of design are you going to use, and whether you could generalize results. Fairly standard stuff in the AP Stat curriculum. And again, we did the same thing. We developed 3 different types of rubrics for this, and this is where we applied the different scoring rules. This was a 3-part question, but the score had to be 4, so how are you going to make that add up to 4? So we played with how you can combine the subpart rules. So we were able to give the exam to about 250 high school students that came on our one Saturday. Once we had all these tests, it's like, okay, we have to rescore them. Not 1 time, not 2 times, 3 times. So how are we going to do that? I had some wonderful colleagues and high school teachers, friends of mine and again, all from doing this mock exam, who came to the school 2 Saturday mornings, bless them, just for pizza and donuts. I mean, these are really dedicated people. And we sat and rescored these papers. We took the 250 exams, divided it into 3 sets, and then we rescored. So rubric 1 was graded twice by 2 different pairs of readers. And no one reader read the same paper twice using the same rubric, because we didn't want them to say, oh yeah, I remember this one, this was bad, or something like that. So we had to make sure that the first time seeing it was with this new rubric. So we went through all the rescoring, and we could see all the things that were happening. Again, once we had those results, we could say, yeah, there were changes, but were they big enough to really make a difference in the operational exam? This is where the simulation study came into place. I'll put up the formula, but it's not going to be on the test or anything. This was, again, based on the total composite test reliability. So we were able to take the 2007 operational exam, develop a simulation model. So all of the things that we saw on the mock exam, we could play with. We could go into the simulation and say, okay, this is what happened on this question, and see what happened on a larger scale. By doing this, well, first of all, this shows how well we did the simulation study. We had to say, okay, is it really that close? And as you can tell, our simulated data is in the 2nd column. I guess I could use that maybe. Haven't used that yet. This was our simulated data, and this matched up fairly well to the operational exam. Once we knew we had a good model, then we could go and proceed. What we were able to show is, with the partial credit, several interesting things happened. The inclusion of partial credit did spread the grades across all ability levels, more so than when we used the standard rubric. It increased inter-rater reliability, and it produced the highest reliability for that item. Now, as far as the one with the subpart new scoring rule that we thought was great, this was going to work well, it didn't work quite as well as we thought, which was kind of interesting to know. We made one where you get 3 halves, ended up being a 2 instead of the standard 1. Well, it ended up that inflated the grades, but not in relationship to the multiple choice section, so that was not a good thing. We had higher grades. I'm sure the students would not have complained, but it didn't really show the ability of the students well. So that one kind of was nice to know that was something that had been nagging at us for a long time, that we really thought that should have been a 2, and it maybe not so much. So. And then, again, when you get down to any end of the research project, you go, well, so what? What does this affect? Well, our reliability, we were able at our highest, when we were doing all the changes, to get the reliability from going up from, it was usually 0.8659 to go up to 0.9165. Again, what does that mean? You know, it goes up, but is that enough to make a difference? Well, we were able to show that that's the equivalent of adding approximately 28 additional multiple choice items. And if you've ever developed tests, that's quite a number of multiple choice items developed, which takes a lot of time and money to do. So a few simple tweakings with the rubric really increased the reliability of the exam, the equivalent of about 28 additional multiple choice items, which was quite impressive at that point. So that was one of the first things we're working on. This one's going to press soon, so we're working on that. Another one is the Got Math Anxiety. Hopefully no one has it after that part of my talk. Or it might come yet. This one, I worked with a friend of mine at the college in New Jersey. She's in math education, and I taught high school math. And as she was going through the pre-service teacher, she goes, you know, the kids, and she does K through 5, really do seem very nervous. So we looked at, I'm getting the signal from the back, okay. Do they all have math anxiety at the same level? And do they feel that it can be effective in the classroom? So basically, we looked at a 2-course method sequence of looking at content and methods class to see that effect on the teachers. Again, using many different statistical techniques, we were able to look at them differently. We were able to look at them by academic major, by level, and to see if certain teachers, maybe early childhood teachers, were more math anxious than the elementary teachers. If so, we could then direct our focus to them differently. So it allowed us a lot better view of that population instead of grouping them all together as elementary teachers. Other projects, and again, I think my time is up. I'm going to get the hook in a second. We looked at, again, and I know another speaker is looking at this earlier, we looked at personal response, the clickers in the classroom and with statistics. And the last one, and again, this is about all I have, this one is a project that I was able to work with my husband. This one got published over the summer. He is an expert in stylometry and a military, amateur military historian, and on his sabbatical went to South Africa and looked at authorship of disputed reports or anonymous text, disputed text, using stylometry and statistical techniques. So again, I think it looks like I do a little bit of everything, but it's fun to be able to apply these techniques to a lot of different fields. So thank you very much, and I'll pass the mic on.